Greenhouse gases such as carbon dioxide trap heat, causing global temperatures to rise. In order to avoid the worst effects of climate change, we need to reduce our carbon emissions to net zero and remove CO2 that's already in the atmosphere. Did you know the mining industry can play a significant role in mitigating climate change by using their waste or tailings to safely capture and store CO2? Certain types of rock are better suited for this type of carbon capture, what we call carbon mineralization. We focus on ultramafic rocks because they typically contain minerals that are highly reactive to CO2. Here we show how a small sample of ultramafic mine tailings can take CO2 out of the atmosphere in real time. Air is isolated between the ultramafic mine tailings and a CO2 sensor. As the air reacts with the tailings, CO2 concentrations in the air start to decrease. The black line tracks the change in CO2 concentration in the trapped headspace above the tailings. The air started with 400 parts per million CO2. But within 2 minutes, about 100 ppm of that CO2 are removed from the headspace. The CO2 is absorbed by the tailings and converted into a solid carbonate mineral, where it is safely trapped and stored from the atmosphere. The CO2 content continues to decline as the tailings absorb more CO2, and nearly 40% of the CO2 is removed in 4 minutes. Some mines with ultramafic tailings are already offsetting 10 to 15% of their emissions through carbon mineralization. This is a scalable idea, and it's already happening. By determining the rate-limiting factors for carbon mineralization, we can accelerate CO2 drawdown and take advantage of existing mining activities to accelerate carbon capture. Some mines have the capacity not only to be carbon neutral, but to provide significant offsets beyond their own emissions. At the CarbMin Lab, we research how to accelerate carbon mineralization, determine where to apply it most effectively, and develop the technology to implement it. Learn more at carbmin.ca.